First, the test papers that we have already discussed. The first or second test, probably the third, I have already discussed in the last session when we meet. So for those papers, at least the basic things, even if it may happen that entire solution you cannot solve on your own, but prepare some notes. Suppose this question is coming from, one question is coming from Newton's second law of motion. There are many questions which requires free body diagram. Clear? So for those questions, you know that how to solve. I will give you some hint that this question requires free body diagram, this question related to this topic. From that, whatever textbook or any book that you have, from that find out the particular concept from which this problem is related directly. Okay, write those concepts, because whenever it is built on some concept, suppose it is based on a banking of road, so you read the theory of the banking of the road, its derivation and calculations given in the book, just write it and read it and write it. So then you have a understand. You may not completely solve the problem right now, but you have an idea that from which portion this question is given, so that I can identify the question, it is of which chapter. It may happen initially that you may not find that which chapter is required for this particular problem, which theory I should apply. So then after this kind of the formulas, the particular concept that you collected and write down as a reference to that question. Okay, this is the preparatory background of the notes. Then try to solve the problem on the basis of those formulas. You know this formula is required for solving this particular problem. Then apply the second step of the preparation. Try to solve those problems, at least some part of the problem. Some question may have many parts. Suppose free body diagram is one part, equation writing is one part, and then the final answer. Try to draw the free body diagram. Then first the working formula, then write the free body diagram, then write the equation, and then finally proceed for the solving of the problem, because ultimately the third stage is required for the exam. Third stage means in exam, when you give the exam, they only find what is correct answer or not, because it's an MCQ exam. They will not see whether you are drawing the free body diagram, writing the equation correctly, writing the concept correctly or not. They only take the final answer. But at the beginning you cannot solve the final answer directly, because you have to prepare yourself to reach to that third step. So for that, first two steps is required. First two steps is, first understand the problem, from which chapter which concept is required to solve this, collect that concept, write it to the, suppose question number 5, it requires Newton's second law, write Newton's second law. Some question number 6 required Pascal's law, write Pascal's law and the related Pascal, one line or two line definition of the Pascal's law, some small theory that you find your book, write it. So when you are going to write it, you have already read it once, read it twice, and in that way you can memorize the laws properly and you can understand. And at that moment, whenever you feel doubt, you can ask sir, me, anyone, okay, who is available at that time. You ask that this concept is little bit I cannot grasp this concept properly, so I require some help. So write it, then your preparation will be at the first stage, then try to solve the problem, then your preparation will be at the second stage, and finally at the third stage you can solve the problem. Otherwise, if you rush with the problem to me or to sir or anyone, then sir solve it, then actually it is our practice and in this way we can get a good score in the NEET, but you cannot. Clear? So this will be the motto first time. I will not discuss the entire solution, otherwise you will only run for the solution. See, the first question, Planck's constant, speed of light in vacuum, Newton's gravitational constant are three fundamental constants. Which of the following combination of this has the dimension of length? So what you have to do? First you have to write down the dimension of all these constants, and then you have to check the options using those dimensions, that which one comes in the dimension of length. That was a very easy question, comes from the first topic. So this question, the required theory is dimensional analysis. Dimensional analysis is the required theory. Clear? So just write down question number 1. Write down question number 1.
So this was the question.
Oh, okay. Question number 1. The required theory is dimensional analysis. So this portion you have to read and find out the answer and prepare the notes. You can write 2 to 3 lines about the dimensional analysis such that it will be a ready reckoner. Because just before the day of exam, there is not much time to read the entire book. And if you are going to read the entire book just before the exam, that I will see the important formulas from the book, then there comes a feeling that okay, I should drop this year and next year I will manage ekdam to the great level. I will reach the summit like this, and the summit can never be reached. So that's why you have to prepare your own notes such that whenever you will see or just before the day of the exam, you can easily brush up the entire topic and go for the exam. Clear? Now, question number 2. Two cars P and Q start from a point at the same time in a straight line, and their positions are represented by XP and XQ, something given. At what time do the cars have the same velocity? So what you have to find? You have to find the instantaneous velocities by calculating the derivatives and then equate them. Equating them, you will get a value of time, and that is the answer. So first, for question number 2, write down instantaneous velocities of particle P and Q should be equated. Instantaneous velocities of particle P and Q should be equated. Clear? This instantaneous velocities you have to calculate and then equate, and then you can find the value of time. Now, question number 3. In the given figure, A is given 15 meter per second square, represents the total acceleration of the particle moving in clockwise direction in a circle of radius 5 radius r at a given instant of time. This is the total acceleration of a particle in the clockwise direction. Okay. Achha. How many accelerations can be involved in this case? Why? See, what is the direction of total acceleration? Is it radial? No. means you can split it into two parts. One is radial, another is tangential. Now radial acceleration we can find by taking the cosine component. See the diagram. A is given, so what will be its component towards the center? That is called the radial acceleration, A cos theta. Then A cos theta means centripetal acceleration, that should be equal to V square by R. R is given, you can find V. Okay. So in this case, don't think that A equal to V square by R. A is the total acceleration, not the radial acceleration only. In this is an example of non-uniform circular motion, where two types of accelerations are present. One is towards radius, towards center, another is along the tangential direction. Tangential acceleration is also present, but the question asks for the velocity of the particle. But velocity of the particle is related to the centripetal acceleration, that is also called the radial acceleration. So A is there, so we will find the component of A towards the center, that means component of A along the radial direction. Then radial component of acceleration is equal to V square by R. So write down. So for the solution of this problem, we have to take the radial component of acceleration and equate it with V square by R, and equate it with V square by R. Okay. So when you are going to solve this problem, you have you require the resolution of the vectors, that is also revised. When you are going to solve this problem, then radial component of acceleration, radial acceleration means centripetal towards center, and it is V square by R. So that portion is also revised from this. And now in solving this problem, you have to remember this point carefully, because in case of non-uniform acceleration, non-uniform circular motion, total acceleration is not towards the center. There is one component towards center, another component is along tangent. Now next question, that is only conservation of linear momentum. We have solved this question many times in previous papers, that is only conservation of linear momentum. Now check, only one component of linear momentum is conserved in that case, and other component of linear momentum is changing. Not the entire linear momentum is conserved, only one component is conserved. So conservation of linear momentum will tell you that along the wall linear momentum is conserved, but that is not the question. Question is to find the impulse imparted. Impulse means the change in momentum that is imparted to the wall. So which component of momentum suffers the change? The component perpendicular to the wall, because initially it is colliding, now it is coming in this way. So this component of momentum is changing the direction. So change is actually twice of this component. Okay, because if you consider this component is mv, then when it is coming back, this component going to be minus mv, then what is the total change? 2mv. mv minus mv, minus of minus mv, mv minus of minus mv. So its change will be twice, not 0, because momentum is a vector quantity. So whenever it completely changes the direction, the total change will be twice, not 0. Next question. A bullet of mass 10 gram moving horizontally with a velocity 400 meter per second strikes a wooden block of mass 2 kg which is suspended by a light inextensible string of mass 5 meter. As a result, the center of gravity of the block is found to rise a vertical distance of 10 centimeter. The speed of the bullet after it emerges out horizontally from the block will be. Any one of you tell me how to solve. Read the question and try to find out the way to solve. Not the entire, I don't require the entire solution, but what are the procedures to solve? Acha, can we apply the formulas of perfectly elastic collision in this problem? Can we apply the laws of perfectly elastic collision or equations of perfectly elastic collision in this problem? What are the laws used in perfectly elastic collision? One is, we have discussed it in the last class. Perfectly elastic collision means conservation of linear momentum and conservation of kinetic energy. Conservation of linear momentum and conservation of kinetic energy. Both are conserved in perfectly elastic collision. Can we use this one? Can we use conservation of linear momentum to solve this problem? First tell me. Can we use linear momentum conservation? Acha, if I ask you what is, just tell me what is linear momentum conservation. What is linear momentum conservation? Momentum before collision and after collision are equal. In a collision problem, if two particles collides, each particle's linear momentum before collision and each particle linear momentum after collision are not same, but sum of the linear momentum of both the particles before collision and sum of the linear momentum of both the particles after the collision will be same. That is called the conservation of linear momentum. Means individually particles one momentum before collision and particle one's momentum after collision are not equal. But if you calculate the sum of the linear momentum of particle 1 and 2 before collision, then collision occurs and particle 1 and 2's linear momentum after collision, these two sum will be equal. But there should be a necessary condition for that. This two particle system can only exert force on each other. They are not acted upon by any external force. Only one can apply force on two, two can apply force on one. But any third member cannot apply force on these two. Then only conservation of linear momentum is valid and you can apply. Now see, in this case there is a wooden block and bullet is colliding with it. So at the time of collision, bullet exerts a force on the block, block exerts a force on the bullet. But These are only the forces exerted by one on the other. They are not given by any third agent. So we can easily apply conservation of linear momentum to solve this problem. So first write down the step 1. Conservation of linear momentum can be applied. Can be applied. Okay. Now check. If it is perfectly elastic collision, then we can also use conservation of kinetic energy. But check whether we can use conservation of kinetic energy or not. Read the problem carefully and tell me whether we can use conservation of kinetic energy or not. Just check whether any other form of energy will enter in the problem or not. Any other form of energy is entering the problem or not. See, the pendulum bob is there. This is the pendulum bob. This is the cord. Bullet hit it like this. So after penetrating, it will rise. See in the problem, it is written that its center of gravity rises. Rises means height increases. Height increases means which energy will come? Potential energy. Gravitational potential energy will come. And that can come only at the expense of kinetic energy. So kinetic energy is not conserved and we cannot treat this problem as perfectly elastic collision. So write down second point, kinetic energy conservation cannot be applied. Kinetic energy conservation cannot be applied. Okay, because potential energy is increasing. Potential energy is increasing. As it gains height, its potential energy will increase. Then we are neglecting friction and all these things. Then total energy, mechanical energy can be conserved. That we can write. That is, initially kinetic energy is there, potential energy 0. Finally, at some position, we consider when it will release from the wooden block, we consider that there is some certain part of kinetic energy and certain part of potential energy. This conservation of mechanical energy can be used because we neglect all kind of friction and all this. Air resistance, this type of friction are not there. So that's why we can use the conservation of mechanical energy, but not the conservation of only kinetic energy. Clear? So write down next point. Resistive forces are not considered here. Resistive forces are not considered here. Initially, when at the level of the bullet, when the bob is here, the entire energy you can consider to be kinetic. Potential will be 0. Now it penetrates, it rises, and then bullet comes out. So at this point there will be some potential energy due to rise in height. Additional will be the remaining kinetic energy. From that you can find the remaining velocity. So two equations I have to prepare. First we have to find out that it is coming, colliding with it, and after collision what happens? Its velocity, the combined mass has some velocity, then this combined mass will rise up to this height and then it will come out. Okay, so why? Because you cannot calculate directly from the beginning and the after, because there is some loss in energy, because the collision is inelastic. See, it penetrates. Penetrates means it joined. Joined means inelastic collision. For a moment it will be inelastic, and as a result kinetic energy conservation we cannot apply. So first, applying conservation of momentum, you have to find out the initial velocity of the combined mass just after the collision. Because bullet is coming, bomb is, and the block is at rest. Then bullet enters the block. Okay. Then you calculate the initial velocity of this one by using conservation of momentum. Then consider this mass has some kinetic energy at this point just after the collision, and with that it rises up to this, means it gains some height, so the velocity will obviously decreases for the bullet, because kinetic energy is some part of the kinetic energy converted to potential, remaining part will be kinetic, so velocity drops, and calculate that velocity. This is the entire problem. So when you are going to solve this problem, this is a multi-concept problem, so you have to analyze all this concept and read all this concept properly, write down, and then go for the solution. Then you have already a revision of the entire topic, collision and all these things, conservation laws, to solve this problem. Clear? See, question number 6. Two identical balls A and B having velocities 0.5 and minus 0.3 meter per second respectively collide elastically in one dimension. The velocities of B and A after collision respectively will be. We don't require any other explanation to solve this problem, because it is much more easy, perfectly elastic. You can use conservation of linear momentum, conservation of kinetic energy, or even if you wish, you can drop the conservation of kinetic energy and write the other equation, that is relative velocity of approach equal to relative velocity of separation in case of perfectly elastic collision in one dimension. So you can also use that. So it's a perfectly elastic collision problem, so just once go through the perfectly elastic collisions theory and solve the problem. If you write down the theory of question number 5, automatically you read or completely the question number 6 technique, because both are almost related questions. Next one, a particle, question number 7. A particle moves from a point minus 2i plus 5j to 4j plus 3k. When a force is applied, how much work has to be done? This is just a dot product. Calculate the displacement between those 2 points and then to calculate F dot S. Displacement between those 2 points, suppose S, calculate that in the vector form and then calculate F dot S for calculating the work done. Question number 8. Two rotating bodies A and B of masses m and 2m with moments of inertia Ia and Ib, Ib greater than Ia, have equal kinetic energy of rotation if LA and LB be their angular momentum respectively. Then see, I will just tell you the formula, try to solve this question. Okay, what is moment of inertia? I equal to mr square. I equal to mr square for a single particle. I equal to mr square. And angular momentum L equal to mvr. We can also write angular momentum as I omega. I omega. So from this, try to solve the problem. Okay. Now, so write down and you will try to solve these problems on your own. Question number 9. A solid sphere of mass m and radius r is rotating about its diameter. A solid cylinder of same mass and same radius is also rotating about its geometrical axis with an angular speed twice that of the sphere. The ratio of the kinetic energy of rotation of sphere to cylinder will be. See, similar type of problem, only you have to know the moment of inertia of each object. For moment of inertia for sphere, solid sphere is 2 by 5 mr square, and for cylinder half mr square, and then proceed for the problem, because you know that kinetic energy equal to half I omega square. Kinetic energy for rotation will be half I omega square. Okay. So using this technique you can have to solve. Kinetic energy for rotation, it will be half I omega square. And moment of inertia for solid cylinder is half mr square, and moment of inertia for sphere, solid sphere is 2 by 5 mr square. Okay. Question number 10. A light rod of length L has two masses m1 and m2 attached to its two ends. The moment of inertia of the system about an axis perpendicular to the rod and passing through the center of mass is. This one is very easy question and you can find easily. Straightforward, just you have to use the formula to find the moment of inertia. Okay. Next, question number 11. Starting from the center of earth having radius r, the variation of g due to gravity is shown by. It is also a straightforward question. Question answer is 2. But for a notes preparation you can write the formulas which are valid in the two domains. That is, when smaller is less than radius of the earth and when smaller is greater than radius of the earth. When smaller is less than radius of the earth, then g double prime will be, acceleration due to gravity will be varying linearly, and when it is outside the earth, then acceleration due to gravity is decreasing with inverse square. So that's why the parabolic fall will come, and inside the earth it will vary linearly and decreases to 0 at the center. So you have to write down the two formulas. You know the formulas that is given in every book. One is the variation of gravity with altitude, another is variation of gravity with depth. Okay, question number 12. A satellite of mass m is orbiting the earth of radius r at a height h from its surface. The total energy of the satellite in terms of g naught, the value of the acceleration due to gravity at the earth's surface, okay, is. So you have to calculate the acceleration, the total energy of the satellite. Energy of the satellite means potential energy plus kinetic energy both. So their sum should be calculated, and you have to show that which of the following is the sum of the total mechanical energy. That is called the total mechanical energy. You have to identify the particular form. So satellite's velocity we can consider as the orbital velocity. Then we can calculate the kinetic energy of the satellite. Orbital velocity root gr, and potential energy we can also calculate. Then we have to find the total energy and identify the form which one is relevant to this total mechanical energy. A rectangular film of liquid is extended from 4 centimeter by 2 centimeter to 5 centimeter by 4 centimeter. Okay, if the work done is 3 into 10 to the power minus 4 joule, the value of the surface tension. Surface tension. What is the formula for surface tension? Force per unit length. Force per unit length. Okay. Surface tension means force per unit length. We can also write it as work done per unit area, that is surface energy stored per unit area. See, this one does not require anything. You can also use the concept of simply dimensional analysis to solve the problem. Surface tension S, we can write, it is defined as force per unit length. So F by L, if I consider that L length of liquid surface is pulled like this by amount X. So this is the length of the surface L. Surface tension force you can draw like this, perpendicular to this length, and now consider this length is pulled by an amount X. So what is the area formed? L into X. L is this length and this is moved by a distance X. So what is the area formed? LX, rectangle. Achha. What is the work done by the force? F into X, because force is there F and it is displaced by X. So Fx is work done and area formed is Lx. So Fx by Lx, that is work done per unit area. Xx cancel, it will be the surface tension. Clear? So F by L also surface tension. Now you can write surface tension is equal to Fx by Lx, means work done per unit area, that is the surface energy. This work done is stored in the surface as surface energy. So this is a very straightforward problem. So write down surface tension equal to surface energy stored per unit area, and surface energy calculated by the work done, that is given. Next, three liquids of densities rho 1, rho 2, rho 3 having the same value of surface tension rise to the same height in three identical capillaries. The angle of contact theta 1, theta 2, theta 3 will obey. Okay. Have you heard about a law called Jurin's law? Jurin's law. Capillary rise. It is in surface tension topic, that if a capillary tube is inserted into some liquid, then liquid will rise in the capillary tube up to certain height because of the surface tension. And in that problem, radius of the capillary tube into height of the liquid column, their product will be constant. Radius of the capillary tube and height of the liquid column inside that rises inside the tube, this product will be constant. If the radius is larger, the height of the liquid will be small. So that law is called Jurin's law. Jurin's law. So this you have to study that portion of the capillary rise to solve this problem. This is also a conceptual problem. You can read those and directly find the answer. The particular law is named as Jurin's law, J-U-R-I-N-E. Okay. Question number 15. Two identical bodies are made of material for which the heat capacities increase with temperature. One of these is at 100 degrees Celsius while the other one is at 0 degrees Celsius. If the two bodies are brought into contact, then assuming no heat loss, the final common temperature is. How to solve? Common temperature means rate of heat loss of both the bodies will be same. That is called the common temperature. Rate of heat loss of both the bodies will be same, then it is the common temperature. So you have to find the answer from that. And what other formulas are required to solve the problem? In this case, it is the change in related to the change in temperature. So obviously the heat required involved in this problem cannot be the latent heat, because latent heat means there will be no change in temperature, but here the change in temperature occurs, so it is for the sensible heat. Sensible heat formula is mc delta T, means mass into specific heat into change in temperature. From that we can calculate the heat. Now one more thing is given in the problem, remember this one, that heat capacity increases with temperature. Heat capacity is not fixed, it is a variable, it is mentioned in the problem, but the formula is related this one of the sensible heat. Okay, so which portion you have to revise to solve this problem? The sensible heat. Sensible heat, mc delta T. And final common temperature means principle of calorimetry. Principle of calorimetry gives us the concept of final common temperature, that loss when the common temperature will reach, then hotter body loses the amount of heat, certain amount of heat, and that is absorbed by the cold body to increase its temperature up to that value. So that's why common temperature. Hotter body is at higher temperature, colder body is at lower temperature. Hotter body will release certain amount of heat, colder body will absorb that amount of heat until both will come to the equilibrium temperature. Okay, so that part of calorimetry you have to read or prepare to solve this question. Next, a body cools from a temperature 3 T to 2 T in 10 minutes. The room temperature is T. Assuming Newton's law of cooling is applicable, the temperature of the body at the end of next 10 minutes will be. It is straightforward question from Newton's law of cooling. Newton's law of cooling, what Newton's law of cooling says? Don't tell me, ask Newton. Rate of heat loss for a body is directly proportional to the difference of temperature between the object and the surrounding. Difference of temperature between object and surrounding. That is the Newton's law of cooling, which is only valid if the difference of temperature between object and surrounding is very small, because for large difference the actual law valid is the Stefan's law, Boltzmann law. So write down rate of heat loss by a body is directly proportional to the difference of temperature of the body and its surrounding, provided this difference is very small. If the difference is large, then it is following that law, T to the power 4 minus T0 to the power 4, that is called Stefan-Boltzmann law. And Newton's law is an approximation to the Stefan-Boltzmann law for low temperature difference. Suppose there is a temperature difference of 30 degrees Celsius, you cannot apply this law. But if there is a temperature difference of say 0.5 degrees Celsius, you can easily apply this law. Question number 17. 1 mole of an ideal monoatomic gas undergoes a process described by the equation PV to the power 3 equal to constant. The heat capacity of the gas during this process is. Heat capacity or the ratio of heat capacity? No, ratio of heat capacity of the gas in this process. See, first you have to find, it is given that PV to the power gamma equal to constant for adiabatic process, and the value of gamma is given 3. Gamma in this case is coming 3. So from that Cp by Cv ratio is 3 and you have to find out 1 mole of ideal monoatomic gas. So you can also find the relations. So you have to use the formula of adiabatic process, that is Pv to the power gamma equal to constant, where gamma will be 3 according to this problem. Pv to the power gamma constant. In this problem V cube is there, means gamma is 3. Gamma is the ratio of Cp by Cv. Then you have to solve the problem. Okay. But there is, I think, one typing error or anything. The heat capacity is required. It is not mentioned. It is in constant pressure or constant volume. Just check. Either you have to say that specific heat capacity at constant pressure or specific heat capacity at constant volume. I think it is specific heat capacity at constant volume, I think. But check both of them and find the answer and then accordingly correct the question. Question number 18. The temperature inside a refrigerator is T2 degrees Celsius and the room temperature is T1 degrees Celsius. The amount of heat delivered to the room for each joule of electrical energy consumed will be. How to calculate? Which logic you have to apply or which formula you have to apply to solve this problem? When you read thermodynamics, you read about a term, efficiency of a Carnot engine, efficiency of any engine, you have read in thermodynamics. Carnot engine efficiency is given by eta equal to 1 minus T2 by T1, where T1 is the temperature of the hot reservoir and T2 is the temperature of the cold reservoir. And related to refrigerator, because refrigerator means reversible heat engine or reversed heat engine. So for reversed heat engine, instead of efficiency, we measure some other thing, that is called coefficient of performance. Coefficient of performance. So that coefficient of performance is required to to solve this problem. It is the similar concept as that of efficiency for the normal engines. Normal heat engines, it is called efficiency. For reversed heat engine like refrigerator, air cooler, anything, we measure the quantity called coefficient of performance. Just once go through that coefficient of performance, you can just put the data and you can solve the problem. A given sample of an ideal gas occupies a volume V at a pressure P and absolute temperature T. The mass of each molecule of the gas is m. Which of the following gives the density of the gas? Use PV equal to nRT and from that write in terms of total mass of the gas. Then calculate mass by volume, that will give the density. So you have to start from PV equal to nRT to solve this problem. হ্যাঁ 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 কেন হবে হ্যাঁ আবার চেঞ্জ করতে হবে পি থেকে PV equal to nRT and from that you have to convert the equation to Boltzmann constant because here R is not used. It is used, Boltzmann constant is used, K. So you have to convert it in terms of the Boltzmann constant. See question number 20. A body of mass m is attached to the lower end of a spring whose upper end is fixed. When the mass m is increased by 1 meter, the time period of oscillation becomes 5 seconds. The value of m is in kg. Which formula we have to use? Formula for time period of a oscillation in a spring. So what is that form? 2 pi root m by k, where k is the spring constant. 2 pi root m by k. Okay. And how to find K? K is not given. How to find lambda? Lambda is not given. How to find K? K is required or not? K is not required because in both the cases springs are same, only mass is changed. So when you divide, K will cancel. When you divide these two, formula is T equal to 2 pi root m by K. So with the first condition you have to write the first equation, then using the second condition you have to write the second condition, then divide these two and then K will be eliminated and you will get your desired result. Okay. Question number 21. The second overtone of an open organ pipe has the same frequency as that of the first tone of a closed organ pipe, L meter long, the length of the open pipe will be. Now second overtone in open organ pipe. Open organ pipe means all order harmonics are present, and closed organ pipe means only odd order harmonics are present. So from that you have to find that open organ pipe second overtone and closed pipes first overtone, these two will be equal, means their frequencies will be same. Equate them and find the length. So write down the formula for frequency of open organ pipe and closed organ pipe are required. Okay. Now question number 22. Three sound waves of equal amplitudes have frequencies n-1, n+1. They superimposed to give bits. The number of bits produced per second will be. What are the number of bits produced per second? Achha, generally what is bit frequency? Generally what is called bit frequency? Means in 1 second how many loud sound we can hear when two sound waves will superpose, or two sound waves of nearly equal frequencies will superpose. They will produce bits. Bit frequency means, and when this bit phenomena occurs, then it is actually we get in 1 second repeated loud sound. So suppose in 1 second we receive 4 loud sounds, so frequency of the bit will be 4 Hertz, means difference of frequency between the interfering waves will be 4 Hertz. So suppose two tuning fork, if produces bits when they are vibrating together, then one suppose 256 Hertz, another is suppose 260 Hertz, then difference of frequency will be 4 Hertz, means bit frequency will be 4 Hertz, and in 1 second we can hear 4 loud sounds. That is called the bit frequency. So you have to read this part of bit frequency to solve this problem. Okay. Question number 23. An electric dipole is placed at an angle 30 degree with an electric field intensity 2 into 10 to the power 5 Newton per coulomb. It experiences a torque equal to 4 Newton meter. The charge on the dipole, if the dipole length is 2 centimeter, is. What are you doing? What is that? Huh? See, an electric dipole is placed at an angle of 30 degree with an electric field intensity 2 into 10 to the power 5 Newton per coulomb. It experiences a torque equal to 4 Newton per coulomb. The charge on the dipole. Okay. How to find this one? Now write down the formula. Torque tau equal to Pe sin theta. Pe sin theta, where P equal to Q into D, that is electric dipole moment. So now torque is given, dipole length D is given, angle is given, electric field is given. So you have to find Q. Torque tau equal to Pe sin theta, where P equal to QD. So all quantities are given, you have to find Q. This is a straightforward problem. Next one. A parallel plate capacitor of area A, plate separation D and capacitance C is filled with 4 dielectric materials having dielectric constant K1, K2, K3, K4. In a single dielectric material is to be used to have the same capacitance C in this capacitor. Then the dielectric constant K is given by. See, it is said that initially if we consider that there are 2 plates and there is no such dielectric, then capacitance will be C. And it is said that when this combination is prepared, the capacitance will be also C. Now in this setup, K1, K2, K3 and this one is K4. Okay. Now see these 3, how they are connected? They are connected in these 3. How? These 3 are connected between same potential difference. So they are connected in parallel. Charge is going like this from one plate to another. Charge is going from one plate to another. Means this portion and this portion have some potential, and between this potential K1, K2 and this one are connected. So these 3 small portions are connected in parallel. Then their equivalent is connected with another in series, because same charge must pass through this one and their combination. Okay. So when this one is given, this one is another, suppose K1, K2, K3 and this one is K. So these are the plates. Suppose these are positive plates, these are negative plates. Let us consider here the potential is V1, here V2, suppose here V3 on this. Then we can consider that this K1, K2, K3 are connected between the potential V1 and V2. So these 3 are connected across the same potential. So they are parallel. So these 3 are parallel. Then their equivalent and this one, suppose K4, are connected in series, because you can replace this 3 by a single. Then you have to consider any charge which goes through K4 must goes through this combination. So same charge then will pass through both of this. So you have to replace these 3 by an equivalent. Then this one and their equivalent have to be find out. So first these 3 individually are connected in parallel, because they are connected between same potential difference. So their equivalent first you have to find out. Let us consider their equivalent will be K prime and then K prime and K4. Now how K prime and K4 are connected? Series, because whatever be the charge going through K4, it will also go through K prime. So now these are connected in series. So then you have to calculate the equivalent capacitance. 3 capacitors, 3 dielectrics connected in parallel. Then their equivalent is K prime. Then that K prime and another K4 are connected in series. Then we will get the ultimate equivalent. Okay. Now, question number 25. The potential difference VA minus VB between the points A and B are in the given figure is. That is the straightforward application of the Kirchhoff's law. So you have to write down only the drops by using Kirchhoff's law. Kirchhoff's voltage law. Question number 26. A filament bulb 500 watt 100 volt is to be used in a 230 volt main supply. When a resistance R is connected in series, it works perfectly and the bulb consumes 500 watt, the value of R. How to solve? You can calculate the resistance of the bulb. Resistance of the filament of the bulb, that we can calculate. How? P equal to V square by R. Power is given, operating voltage is given 100. Then using the formula P equal to V square by R, we can find the value of the resistance of the filament. Now it is connected in series with another resistance. Means two resistances, you have to calculate the sum of two resistances, because series combination equivalent will be sum. Then it will consume 500. Then for that equivalent resistance you can calculate the current. Then for that equivalent resistance you can find the current, because 230 volt is given. Calculate the equivalent resistance, you will get the current, value of the current, because 230 volt is given. Then that current is passing through the filament as well as through the other resistance which is connected in series, and in series combination same current will flow. Then across the filament of the bulb, how much power is developed? 500 watt, and that can be written as I square into R. I square into R of the filament. Clear? So we can write in this way. First we will consider this one is a bulb and there is a resistance 230 volt. This one is suppose R1, this one is suppose R2. This is the bulb filament resistance, this is R2. What you have to find? You have to find this R2. So first, how can we calculate? We can use R1 equal to V square by P from the data given for the bulb. Rating of the bulb is given 500 watt 100 volt. So we can find R1 100 into 100 by 500. So it is 20 ohm. This one R1 is 20. Then we can calculate current I. I will be 230 by 20 plus R2. I will be 230 divided by 20 plus I2. Then this current will not only flow through R2, this current will also flow through R1. Then how much power is developed across R1? That is I square R1, and that is given 500 watt. Because it is mentioned that when this resistance is connected, the bulb consumes exactly 500 watt. Then put the value of I and solve for R2, because other values R1 is known, only R2 will be unknown in that case. So you have to use this value of I here. R1 is already found, that is 20. Put here 20, and in the expression for I there will be only unknown quantity R2. Then from this equation you can find R2. Okay. Question number 27. A long wire carrying a steady current is bent into a circular loop of one turn. The magnetic field at the center of the loop is B. It is then bent into a circular coil of n turns. The magnetic field at the center of the coil is of n turns will be. At the center of the coil, if there is one turn, what is the magnetic field? Mu naught I by 2R. Mu naught I by 2R. At the center of a circular current carrying coil of single turn, B equal to mu naught I by 2R. Then check which quantities are changed if I take n times turns. If the number of turn will be n, then which quantities will change, and accordingly find how much multiple of the single turn. For single turn, field at center is given B. Then write down for n turns what will be the value of B, and then calculate the ratio. Whether B equal to NB or it is n square B, just you have to find that. Okay. So question number 28. A bar magnet is hung by a thin cotton thread in a uniform horizontal magnetic field, and it is in equilibrium state. The energy required to rotate it by 60 degree is W. The torque required to keep the magnet in this new position is. Torque is calculated by MB sin theta. Torque is calculated by MB sin theta. Write down. In case of magnet, MB sin theta, where M is magnetic dipole moment. Now, what is W? W equal to MB cos theta. That is the potential energy is equal to work done. The same formula as that of electric dipole is applied. In electric dipole it is P cos theta, and here it will be MB cos theta. W. Then what you will get? You will get two formulas. One is tau, that is equal to MB sin theta and W equal to mb. Divide these two, you will get tau by W equal to now check which quantities are given. W is given, tan theta you know, you can find the torque. Tan 60 will be root 3, so the answer will be root 3 W. Okay. Next, question number 29. An electron is moving in a circular path under the influence of a transverse magnetic field. Magnitude of the field is given if the value of E by m is 1.76 into 10 to the power 11 coulomb per kg, the frequency of the revolution of the electron. How to solve? If I consider electron is revolving in circular orbit, then I can say that there is a current involved in a current is moving in a circular loop. Now this current can be written as E by T, capital T, where T is the time period of revolution. So write down I equal to E by T, capital T. E is the charge of an electron and capital T is the time period of revolution. Now, so that is not required, I think. Without this one you can solve. This is not required. Write down the formula. Just it is a problem of a cyclotron. mv square by r equal to qvb. mv square by r, that is the centripetal force. It will be provided by the magnetic force. Then the electron will rotate in the circular path. mv square by r equal to qvb. That is the motion of a cyclotron. Now, so we have written mv square by r equal to qvb, but for electron q is replaced by, now what we have to find out? Frequency of revolution. So E by ratio, so V by R we can find, that will be E by M into B. Okay. V by R we can find E by M into B. Now we can write this V equal to R omega. It is moving in a circle, so V can be written as R omega. But frequency of revolution means natural frequency, that is 2 pi f. So omega can be written as 2 pi f. E by M into B. Then you can calculate f, that is EB by 2 pi M. So B is known, E by M is known, 2 pi is already known. So you can find the value of frequency. Frequency of revolution of the electron. Because in this case the magnetic field is applying a force on the electron towards the center. That this problem is similar to the motion of a cyclotron. cyclotron is the modern particle accelerator. So any charged particle when used in the modern particle accelerator, they will accelerate and produces electromagnetic energy. They will release electromagnetic energy. Which of the following combinations should be selected for better tuning of LCR circuit used for combination? Tell me. Which portion of the topic is required? Alternating current, LCR circuit, but which combination should be selected? Impedance. Can which combination should be selected for better tuning? Better tuning, remember. What do you mean by better tuning? See, whenever we are going to tune a particular radio station, so for better tuning, one quality should be measured, that is called the quality factor or the bandwidth of the signal. Quality factor or bandwidth related to the topic sharpness of resonance. Sharpness of resonance means resonance curve in the series LCR circuit should be like this. This type, not this type. Suppose you are going to listen 98.3 FM. 98.3 FM. So this is 98.3, but in this way 98.3, 96.2, 100 FM all will be at the same level. So for all, resonance will be flat. So all station sound will be overlapped. So this is a bad resonance curve. And this one is sharply picked resonance curve. So for the tuning purpose, we always require a sharply picked resonance curve such that it can distinguish between the frequencies properly. How many of you heard about Lata Mangeshkar? Lata Mangeshkar, famous singer, Bharat Ratna, Lata Mangeshkar. The song "ऐ मेरे वतन के लोगों जरा हाथ आँख में भर लो पानी", वो जो गाना वो लता मंगेशकर ने गाया था in front of Jawaharlal Nehru, Prime Minister at that time, and even Jawaharlal Nehru crying. So she is called the Nightingale. His voice is so sweet that she was called the Nightingale. And how many of you heard about the name of Ranu Mondal? लता मंगेशकर उतना नहीं सुना, रानू मंडल के बारे में तो रील्स में आता है. अच्छा, so suppose In one station they are playing the Lata Mangeshkar's voice, and in other station they are playing Ranu Mandal's song. If this is the resonance curve, then there may be overlapping, and you can feel that Lata Mangeshkar is singing like Ranu Mandal. So that's why sharply picked resonance curve is required, such that this type of controversy will not generate. Clear? So sharpness of resonance. Now you have to read those portion of sharpness of resonance. There are two measurements of sharpness of resonance. One is by measuring the bandwidth. Bandwidth low means resonance curve is sharp. And another measurement is called quality factor. Quality factor means if quality factor is high, resonance curve is sharp. So you can measure either property to solve this question. So you have to check from the following combination that which one will give you better resonance curve. You can measure either quality factor, then which combination will give you the large value of the quality factor, that you have to calculate, or if you measure in terms of bandwidth, which combination gives us lowest bandwidth. So you have to read these two portions, sharpness of resonance, and under this sharpness of resonance two measurement, one is quality factor, another is bandwidth, to solve this entire question. Clear? A uniform 31. A uniform magnetic field is restricted within a region of radius r. The magnetic field changes with time at a rate dB dt. Loop 1 of radius capital R greater than r encloses the region small r, and loop 2 of radius capital R is outside the region of magnetic field as shown in figure below. The EMF generated. It is a question of Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction. You have to apply Faraday's law to calculate this one, and the answer will come in the form of dB dt into area, and that particular area which has to be taken. It is either pi r square or pi capital R square. Now you have to find out which one is proper, because it is given that loop 1 has a magnetic field is restricted within radius small r. Within radius small r magnetic field is restricted, not up to the capital R magnetic field is present. So you have to decide accordingly. Now 32. The potential difference across the resistance, capacitance and inductance are 80 volt, 40 volt and 100 volt respectively in an LCR circuit. The power factor of this circuit. Power factor means cos phi. Cos phi power factor. That is R by Z. R by Z. Where Z is called the impedance of the circuit. So R by Z will be cos phi, which is called the power factor. So you have to find this value. (33) A 100 ohm resistance and a capacitor of 100 ohm reactance are connected in series across a 220 volt source. When the capacitor is 50% charged, the peak value of the current. So what is the peak value of the current? E0 by Z. E0 by Z is the peak value of the current. So write down I0 equal to E0 by Z. E0 by Z. Okay. Now what is Z in this case? Root over of R square plus 1 by omega square C square. because xc means 1 by omega c. So r square plus 1 by omega square c square. It is under root. Now you have to calculate it by considering that 50% is charged. Then what will be the value of the peak value of the current? Now, two identical glass two identical equiconvex lens of focal length f focal length f each are kept in contact. The space between the two lengths is filled with water, then the focal length of the combination. How to find? Combination of lengths, that portion is required. How many of you remember combination of lengths? You can add the power directly, then 1 by f will be equal to 1 by f1 plus 1 by f2, but here one change will occur because some liquid is added. So you have to consider the presence of the liquid and write down the equivalent focal length. An air bubble in a glass slab with refractive index 1.5 near normal incidence is 5 cm deep when viewed from one surface and 3 cm deep when viewed from the opposite surface. The thickness of the slab. First tell me which portion's problem it is. Based on which concept? Real depth and apparent depth. Because whenever you are seeing almost normally inside the glass to the bubble, then you are actually measuring the apparent depth. So real depth and apparent depth problem. Suppose an object is inside water. When we see from above, we have a feeling that the object is shifted upward. So same type of problem is this one. The apparent depth will be shorter in this case than the real depth. So from that you have to find the thickness. So write down real depth and real and apparent depth problem. Next, the interference pattern is obtained with two coherent light sources of intensity ratio n. The interference pattern, the ratio of Imax minus Imin by Imax plus Imin. This one is actually a very common question. So write down the expression for I in interference. I equal to I1 square, I1 plus I2 plus 2 root I1 I2, 2 root I1 into I2, I1 and I2 both their product is under root into cos delta, where delta is the phase difference between the interfering waves. Now in this particular problem, Imax and Imin, both the I's will be, I1 and I2 will be equal to same. I1 and I2 both values will be same in this case, and you have to consider, no, intensity ratio is given n. So if you consider I1 equal to n times x, then I2 will be simply x. Then find the ratio. So which formula you require? First you require this one, that total intensity will be I1 plus I2 plus 2 root I1 I2 into cos delta. Now it is given that if I1 equal to n times x, then I2 will be equal to x. Then only the ratio will be, one is intensity will be n times than the other. According to the problem, it is given that ratio of the two intensity of ratio is n. So I1 by I2 is n. So I considered that I1 equal to nx, then I2 will be equal to x, then their ratio will be n. Just you have to put these values in the above equation for I considering the maximum and minimum. When maximum comes, then cos delta will be plus 1. When minimum comes, cos delta will be minus 1. And accordingly you have to put to find I minimum and I maximum. Then you have to calculate this one, I max minus I min by I max plus I min. Okay. Next problem. This is coming from Young's double slit experiment directly. A person can see clearly objects only when they lie at 50 centimeter and 100 centimeter from his eyes. Means near point and far point. In order to increase the maximum distance of distinct vision to infinity, the type of the power of the correcting lens the person has to use. See, far point is at 400. So at the 400 the light will converge. So if you consider that the object is at 400, then the light ray will refract and converge to his retina. Converge to its retina means, hey, why are you laughing? What? So at the 400, if the object is present, then the image will be formed on the retina. Now you have to shift this 400 up to infinity, because normal eye far point is at infinity, far point. Near point is at 25, but you have to change the far point, not the near point. It is given that near point of vision is 50, far point is 400. Now you have to shift the far point to infinity such that the object at infinity will be focused at retina, because far point comes closer to 400. Then which type of lens should be used? Convex, such that that object would be focused on the retina. A linear aperture whose width is 0.02 centimeter is placed immediately in front of a lens of focal length 60 centimeter. The aperture is illuminated normally by a parallel beam of wavelength 10 to the power minus 5 centimeter. The distance of the first dark band of the diffraction pattern from the center of the screen. First you have to use the formula A sin theta equal to n lambda. A sin theta equal to n lambda. That is for First, which fringe, bright or dark? Dark. For dark it is not lambda, for bright it is lambda. Lambda means phase are in equal phase. Dark fringe means they should be in opposite phase, means phase difference should be 180 degree, not 360. Then it is integral multiple of lambda by 2. So a sin theta equal to lambda by 2 for dark fringes. For first dark, then n should be 1. So a sin theta is simply lambda by 2. Now a is the slit width that is given, aperture of width given, wavelength given, then focal length in front of a lens 60 meter, the aperture is okay. So first you calculate from this the value of theta. Value of theta you can find sin theta. A sin theta equal to lambda by 2. So using this you can find the value of sin theta or theta. Then the distance from the center of the screen. Then you have to find the distance. How much? By using, now the Pythagoras theorem is used, or write down the sin theta for this diagram. This distance is given, you have find sin theta by this formula, then this distance and this one. Then if sin theta is found, you can also find tan theta. Then this distance is known, then you have to find this distance, that is from the center at how much distance the first dark fringe will form. So the diagram is like this. This one is x. So now that x has to be find out. This point is the first dark. So by using that formula, first you have to find the value of sin theta. Then once we got the sin theta, we can also find the value of tan theta. Then you have to calculate from this that tan theta equal to x by t, then find the value of x. Now, question number 39. Electrons of mass m with de Broglie wavelength lambda fall on the target in an X-ray tube. The cutoff frequency lambda naught of the emitted X-ray. Only the relationship required between de Broglie wavelength and the cutoff frequency, that relationship required. So just go through the X-ray experiment and you can find. So whenever you will read all these hints that I have given, don't only read the portions, the concept that I have said, collect it from the book. Write it as per the question. Question number 1, keep some space, write down the particular formula and the portion, read it from the book and write the whatever you learned from that. Write 2 to 3 line formula and adjacent any law if you require. Then keep some space left such that when you will retry this problem, then you can use this space to solve the problem, and remembering that this particular theory is required to solve this problem. Then your second level note is completely prepared at the moment. First level is that read those portions that I have given as a hint, write it, the particular formula or the derivation, anything in the given in the problem or any definition that you think that it is required, write it and keep some space such that when you will prepare the second level of notes, you can solve this problem at that position by reading that particular concept. Okay. Now, question number 40. Photons with energy 5 electron volt are incident on a cathode C in a photoelectric cell. The number of the maximum energy of emitted photoelectron is 2 electron volt. When photons of energy 6 electron volts are incident on C, no photoelectrons will reach the anode if the stopping potential of A relative to C is. Which portion you have to study for this? Einstein's equations of photoelectric effect. Einstein's equation of photoelectric effect. Question number 41. If an electron in a hydrogen atom jumps from third orbit to second orbit, it emits a photon of wavelength lambda. When it jumps from the fourth orbit to the third orbit, the corresponding wavelength of the photon will be. Corresponding wavelength of the photon will be. Which one required? Which formula? See, modern physics is mostly formula based question will come. So you have to remember all the, because in mechanics, even if you forget the formulas on the basic concept, drawing the free body diagram, completing the free body diagram, we can solve the problem. But in modern physics part, you have to remember the different formulas, otherwise it is very difficult to solve, because modern physics questions are easy. But if you remember the formula, if you can't remember the formula, you cannot solve it. Mechanics problems are difficult, but if you know the concept, there is no such formula. Drawing the free body, completing the free body diagram, writing equation of motion, you can solve. Write down 1 by lambda equal to R H, R suffix H, suffix H, bracket 1 by Ni square minus 1 by Nf square, Rydberg formula for spectra. So from that you can find out. The relation of the wavelength directly. Okay, because it is given hydrogen atom, the hydrogen atom Rydberg formula is valid, because Rydberg formula gives us those series of the spectral lines like Lyman series, Balmer series, Paschen series, all these things. So by considering the first, the from third orbit to second orbit, third orbit to second orbit means initially 3, then going to 2, and then again you have to calculate. Fourth orbit to third orbit, like this. Can any one of you tell me from which formula this Rydberg formula will come? Energy formula, Max Planck, E equal to NH nu. From that, nu can be written as C by lambda. Acha. For C, transistor amplifier. Transistor is there in the syllabus. Transistor and all logic gates. Logic gate in the syllabus, but transistor is not, no more in the syllabus. Diode is there. Okay. So come directly to the 44. Now 42 is there. 42 is there. The half-life of a radioactive substance is 30 minutes. The time taken between 40% decay to 85% decay of some radioactive substance is T half is given. So which one to start? You can start from the basic law, n equal to n0 e to the power minus lambda t. N equal to n0 e to the power minus lambda t, radioactive decay formula, where n0 is the initial number of radioactive atoms, radioactive nuclei, then n0 is the initial number, n is the present number of the radioactive nuclei, then remaining will be decayed. So n will be the undecayed nuclei after certain time. After certain time t, the number of undecayed nuclei in the sample will be n, that is equal to n0 e to the power minus lambda t. Acha, okay. This one is a formula, basic formula from which you can try. You know, okay. So by eliminating lambda, there is another formula in your book. You will find this one. Then you can use also that formula to solve it. But the basic formula, that formula comes from this particular one. N equal to n0 e to the power minus lambda t. So you can convert it into that formula by eliminating lambda, by using the formula for T half. Achha, next one is the question number 44. See, C amplifier transistor is already cancelled from the syllabus, so we will not discuss that. Question number 44. The given circuit has two ideal diodes connected as shown in figure below. The current flowing through the resistors R1 will be current flowing through the resistance R1 will be which one? It is very easy. Do it right now. Question number 44. কত আচ্ছা PN junction diode, in which bias PN junction diode will allow current to flow through them? Forward bias. If PN junction diode is in reverse bias, it will not allow current to flow through them, because reverse bias current is only due to the minority carrier and that is negligible. Okay. Now check, this is a DC voltage source. In this problem number 44, the voltage source is a DC source. Now whenever a PN junction diode is used like this, then it is called the P terminal and it is called the N terminal. P terminal, that is called N terminal. And if the battery voltage is giving like this, then it is called forward bias, means positive terminal is connected to P, negative terminal is connected to N, then it is the forward bias. If it is battery polarity is changed, then it will be reverse bias. Now check, in this circuit which diode is forward biased and which diode is reverse biased in problem number 44? D1 is reverse bias always and other one is forward bias. Okay, so D2 is forward bias, D1 is reverse bias. So D1 will not work. D1 will not work because D1 is in reverse bias. So D2 will only work. Then one resistance, the current starting from the battery will suffer one resistance 2 ohm. Then it will not go through that channel in which D1 is connected. So it will directly transfer to the D2 and goes through the R3. And same current goes through R1 and R3, and as if the branch with D1 is completely neglected. So what is the equivalent resistance of the circuit? 4. So 10 by 4 is 2.5. So that is the answer. Which one? C. Current tries to go from this, R1 is given 2 ohm. See, after this there will be two branched normally if there is only resistance, not the diodes. But in this case, this is the N terminal, this is the P terminal, this is P, this is N. So current tries to go. So which branch is connected here? Positive. So this one is in reverse bias. So reverse bias, no current will flow through this, so we can consider that this branch is not at all present. It is in forward bias. So all current will flow through this. So this resistance and this resistance, these two will be occurred by the current. The same current flows through this and again this. Then total resistance will be series 4. Battery is 10 volt. So what is that current? 10 by 4, 2.5 ampere. Because that channel containing D1 will be completely cut off, because D1 is in reverse bias and diode will not operate in reverse bias except Zener diode. Okay, next, what is the output Y of the following circuit when all the three inputs A, B and C are first 0 and then 1? See, this first one, P, that is given as P, which gate? It is called AND gate. P is a AND gate. And Q, NAND gate. P is an AND gate and Q is a NAND gate. Here A and B given. So on this channel it will be A into B AND gate. Then this one is given another input C. Okay, C is given. So now first it will produce what? A into B into C, and then not. So its complement, that is equal to Y. Now check by considering all of them 0 and then all of them 1. So when all of them 0, 0 into 0, 0, another 0, 0, its complement will be 1. And second one, all will be 1, its complement will be 0. So 1 comma 0, that is number 3. If all inputs are 0, A0, B0, C0, then entire product will be 0's complement will be 1. So all 0 means 1, and all 1 means 1's complement, that is 0. So 1 comma 0 is the answer. Question of option number 3.
There is another formula, R equal to R not e to the power minus.
হ্যাঁ করতে পারো, এটা রিমেনিংটা নিয়ে করতে পারো, অসুবিধা কি? দাঁড়াও দিয়ে যায়, বলো।
So why can't the option be 1, sir? Why can't the option be this one, sir?
This is why.
Yes, sir.
So if you put first one all 0, 0, 0, 0, 0, so y equal to 0's complement. What is 0's complement?
1.
So option 1 how much? Option 1 will be the answer if there is another, if this one is AND gate. Since it is NAND gate, this bar will come, means complement will come, and then option 3 will correct. If there is no bar, it is only another AND gate, then option 1 will be correct. Okay. So what you have to do, all the questions related theory that I have said, that you have to write in the copy as question number 1. This theory is required, this is the working formula. If it is a information based question, then only sufficient information or the theory is written, no working formula like that. So write this one and then try to first complete that portion, the theoretical part that you have to collect it for solving that particular problem. First write down, then you have an idea that this question comes from this topic, this question comes from this topic, and how much emphasis I have to give to some particular topic. Okay, then you can understand properly. Suppose if you can't find the particular topic in the book, then it is definitely that you have very poor concept in that, and you have to work on that particular chapter more and more. Clear? Then after that, complete the first and second level of notes, then go to the third level of notes, means directly solve the problem using those formulas. Clear? And you have to do it from today. So if you left these things for once upon a time, there will be some time when we will do it, then you will forget all these things. So today I discussed this. So from the study sessions that you have, take your books, NCERT books or any other book that is available to you, collect those things, write it properly, and during the understanding, if you will have any problem, you will come to me or to the sir, we will help you. Okay, because you are going to read something that is not discussed here directly. You may find that this one I have studied in long before, 1 or 2 years before, and I forget. Okay, this type of things can happen. Come to us and we will help you, and then prepare the notes properly, because otherwise many things we can say, and it is, you will hear these things, and if you don't write you will forget. So we have to again and again tell the same problem, solve the same problem to you, and actually that is not very beneficial to you. Clear? Okay, so we will discuss some particular concepts. The particle dynamics portions we have already completed in the last visit. I think the last topic that I have discussed is perfectly elastic collision in one dimension. Perfectly elastic collision in one dimension, that we have discussed. But after perfectly elastic collision, there are two more types of collisions. One is perfectly inelastic collision and partially elastic collision, and another case is there, perfectly elastic collision in two dimension. Two dimension, head on, not head on. So suppose this one is an object of mass m1, it is moving along this direction with velocity u1. We consider another object of mass m2, it is also moving along this direction with velocity u2, and we consider here that u1 is greater than u2, so they will collide, and we consider that after collision both of the objects actually join together, and this combined mass m1 plus m2 is moving with velocity v along this horizontal direction. Both the masses collide, and after collision they join together and they are moving. Okay. Now see, this is an example of perfectly inelastic collision. Perfectly inelastic collision. Now why it is inelastic? Inelastic means you can write the conservation of linear momentum. So using conservation of linear momentum, I can write m1 plus m2 into v, that is the final linear momentum, that is equal to sum of the initial linear momentums. See, here I drop the vector sign from the velocities because the motion is taking place in one dimension. So vector sign is no more required in this problem. Now m1 plus m2 into v, this will give you the final momentum, and m1 u1 plus m2 u2 will give you the initial linear momentum. Now you cannot write conservation of kinetic energy, because kinetic energy initial and kinetic energy final will not be equal. Why they are not equal? You can say that both the body will join together, that's why it is not equal. So I can argue that why, if it is joined together, then why kinetic energy is not equal? If two body joinings, then what happens such that kinetic energy is no more equal? Yes, when both the body joins together, it will be joined due to some attractive force. And attractive force means some kind of potential energy will be developed. Otherwise attractive force will not generate, for which is responsible for joining. Okay. So some potential energy will be developed, but potential energy cannot be produced on its own. It is coming from at the expenditure of initial kinetic energy of both the masses. So finally when the combined mass will move, its kinetic energy will be less than the sum of the kinetic energy before the collision. Clear? Sum of the kinetic energy before collision is less than sum of the kinetic energy after is greater than sum of the kinetic energy after collision. So after collision it drops because some portion converted to potential energy such that both the bodies will combine together. Clear? Now in this case only conservation of linear momentum is sufficient to tell us the final value, because final velocity is only one, v, because in case of perfectly elastic collision two unknown quantities are there, v1 and v2. That's why we require two quantities, one is kinetic energy conservation, another is linear momentum conservation. But here I have only one equation and number of unknown is also one, so it is sufficient for me. We do not require kinetic energy conservation for solving this particular problem. I can directly write from here that v equal to m1 u1 plus m2 u2 by m1 plus m2. So second equation is no more required to find the velocity. One equation is sufficient. Okay. Now you can also check one thing, that difference of kinetic energy you can calculate, Ki minus Kf. Ki is the initial kinetic energy, Kf is the final kinetic energy. So what is Ki? Half m1 u1 square plus half m2 u2 square minus half total mass is m1 plus m2 into v square. Into v square. But what is v? That value, m1 u1 plus m2 u2 by m1 plus m2. So I can write m1 u1 plus m2 u2 whole square divided by m1 plus m2 whole square. This one. The entire value of v I have substituted here for v square. Okay. Now I write the final answer. When you study, you can solve this one. The final answer will become half m1 m2 by m1 plus m2 into u1 minus u2 whole square. This one will come. If you solve this, simplify this one by taking LCM and all these things, you will get this result. Half m1 m2 by m1 plus m2 into u1 minus u2 whole square. After simplifying, we will get this result. Now this equation, last step, clearly shows that Ki will be greater than Kf. Why? Because m1 m2, this cannot be negative, mass cannot be negative. So m1 m2 by m1 plus m2, this combination will always give a positive value. Now u1 minus u2, see there is whole square and it is mentioned that u1 and u2 are not equal, so their square is always positive. So entire term is positive, means Ki should be greater than Kf, otherwise it is not positive. So initial kinetic energy is always greater than final kinetic energy, means some kinetic energy is lost during collision. That's why the bodies coalesces to form the bonding. Bonding means some potential energy will be developed, and that can be produced at the expense of some kinetic energy. Okay. Done? Next, if I consider that these bodies are moving along the same direction with speed u1 and u2 as before, and u1 greater than u2, bodies will collide at some time, and after that both the bodies are again separated. So they will collide at some position when they are in contact, but after that the bodies are again getting separated. It is moving with velocity v1, it is moving with velocity v2. Like the problem that I discussed in the paper, that bullet is hitting the wooden block. Sometime it spends within the wooden block, then completely penetrate and then comes out. So we consider that during collision for some time they are moving together, and after that they are separated from each other. Means you can use linear momentum conservation in this situation, but you cannot write conservation of kinetic energy though the bodies are also separated. So this problem of collision has some similarity with perfectly elastic collision, that bodies after collision are separated, but some similarity with inelastic collision also, that kinetic energy is not conserved. This type of collision problem is called partially elastic collision. Partially, it has some property common to perfectly elastic, has some similarity with perfectly inelastic. So for this we can only write conservation of linear momentum m1 v1 plus m2 v2 equal to m1 u1 plus m2 u2. But you cannot write kinetic energy conservation for this problem. So there is some loss in energy though the bodies are separated. Previously the loss is maximum, but now the loss is not maximum, but still some loss is there. Okay. Now the real problem occurs. In perfectly inelastic collision there is only one unknown, that is capital V, because both the masses combined and it is moving with a single velocity. So one equation is sufficient to find that. But here two unknowns but only one equation from the conservation of linear momentum. Then how to solve? Two equations but only one unknown. Two unknown, one equation. How to solve? In mathematical principle we cannot solve, because we require at least one more equation. Then kinetic energy conservation is not there. Then how we can prepare the second equation? We can use the technique of relative velocity of approach and relative velocity of separation. In case of perfectly elastic collision in one dimension, we find that relative velocity of approach and relative velocity of separations are equal. Here they are not equal. So we can write that relative velocity of separation, that is v1 minus v2, will be equal divided by u1 minus u2, that is defined as some constant E called the coefficient of restitution. Coefficient of restitution. So the value of E should be given, otherwise you cannot solve for V1 and V2. Okay.